Hello, friends. We're continuing our study of geometry. We're on lesson 6. We're talking about some angles today, some angle theorems, and that sort of thing, some relationships. So let's get to it. The first angle relationship we're going to talk about isn't necessarily about how angles are, if they're next to each other or not, but just that any two angles that add to 90 degrees are said to be complementary. Okay. The way that you can remember this is that to compliment someone is always the right thing to do. Right? It's right to compliment someone. Which, I mean, morally, actually, that's not entirely true. Like if somebody's shooting somebody else, you complimenting them is not the right thing. Like, hey, that was a great shot. Went straight to the heart. Um, we don't. It's not always the right thing to do to compliment someone. But for the sake of trying to remember this, that complementary means they add to 90 degrees. They add to a right angle. So you could have any two angles in the universe. If one of them is 30 degrees and the other one is 60 degrees, they add to 90 degrees. They are complementary. They don't have to be right next to each other or even anywhere near each other. Two angles that add to 180 degrees are said to be supplementary. Okay, and you can just remember supplementary is not complementary. Complementary, they add to right angle. So supplementary means they add to 180 degrees. And again, they don't have to be next to each other. However, if we have 180 degrees, that's a line, right? And so if a situation like this where there's a line coming from two lines intersecting, or a line segment here, then these two things, these two angles are called a linear pair because when you have them together like this, when they're adjacent, they form a line. Okay. And these are supplementary angles. Linear pair angles are always supplementary. That's going to be actually a theorem we see later in this lesson. Main point, supplementary angles add to 180 degrees. The congruent complements theorem, I abbreviated theorem. I got a little lazy, so I just wrote THM, which when you're writing out your answers, usually that's an accepted convention. If you're working with a teacher, you got to ask, is it okay? Even congruent, you can use the congruent symbol. As far as I'm concerned, that's okay. But, what your teacher wants is what you've got to go by. So anyway, if two angles are complementary to the same angle, by the way, there's a difference between if you give somebody a compliment that has an I in it. Complementary, as it's used here, is just has the two E's, complementary, as opposed to complimentary comments that you make. So if two angles are complementary to the same angle, then they are congruent. So what we're saying here is that angle GEO and angle TEM are both complementary to angle OEM. So GEO and OEM add up to 90 degrees, and that looks like it's 90 degrees. Let me redo that. Okay, so that's a 90-degree angle, but also OEM and TEM is 90 degrees. That one is not as obvious, but I'm gonna put the symbols in there. Okay, now, since GEO, since this angle and this angle are both complementary to the same angle, that means that they must be equal to each other. They must, the angle measurements must be the same. And so those angles are congruent. Again, it's called the congruent complements theorem. Two angles that are congruent to the same angle must be, or sorry, two angles that are complementary to the same angle must be congruent with each other. Okay. And then it works the same way for supplementary angles as well. That if we have two angles that are supplementary to the same angle, then uh, they must be congruent to each other. So here's an example. Angle MTA, and angle HTE are both supplementary to angle MTH. So let's put some labels in here. So we're saying is that this angle is 180 degrees, and also that this angle is 180 degrees. Okay, and so that means that uh, angle MTA must be congruent to angle HTE. This leads us then to the linear pair theorem, that if two angles form, or actually this doesn't lead us to the linear pair theorem, we're going to get to something else in a minute, the vertical angle theorem. But the linear pair theorem, I alluded to this before, said it before. In fact, I just copied the diagram from the previous example of supplementary angles, that if we have two angles that form a linear pair like this, then they are supplementary. Okay, very simple. And it makes perfect sense because you can see actually here that they have to add to 180 degrees. They have to add up to just a line angle here. So we say that angle MAT and angle TAH are a linear pair. Therefore, they are supplementary. That's it. And then a vertical angle, vertical angles share a vertex. If we've got two lines that intersect, or two segments, or two rays, whatever it might be, if they intersect, these opposite angles that share a vertex are vertical angles, right? And I'm not undergoing a seizure. I'm putting the emphasis on vertical and vertex for a reason, because that's where the name comes from, right? Vertical angles share a vertex, and they're opposite of each other in this kind of a way. And it really came right out of what we did here. We can use this to prove, to kind of reason to ourselves that uh, that these two angles have to be congruent to each other. So angle MTA is congruent to angle HTE. So now here's an example. A bunch of things happening in this diagram. I want you to find the values of the letters X, Y, Z, and P. What do we know? Just let's take a look at this thing. Well, we've got a couple of lines going through here, right? So here's a line, and here's a line. And so with these two, we know that X and P have to be congruent because they're vertical angles. I've got DMN is a right angle, and it's being broken up by this segment here, segment AM. But angle AMT is also a right angle. And so that means I've got a couple of pairs of angles that are complementary. Angle DMA is complementary to angle AMN. Right, so these two have to add to 90 degrees. And so I know that X has to be 60 degrees, right? If we want to write it out kind of step by step so you can see it, let's see. The measure of angle DMA plus the measure of angle AMN equals the measure of angle DMN. And then we substitute in, this is 90 degrees. And we know that AMN is 30 degrees. So the measure of angle DMA plus 30 equals 90. You subtract 30 from both sides. And so the measure of angle DMA equals 60 degrees. That's how we show that step by step, that we get that answer. Now, I could do the same thing to find what Y is, but I see that DMA and NMT are both complementary to AMN. And so I know that whatever X is, Y has to be the same. And so Y is also equal to 60 degrees. Okay, so how do I figure out what Z is? Well, I know that I can tell I have a line here, right? And in this line, I have all of this angle, kind of this big angle. I'm going to draw with a black line. This whole big angle right here is 60 plus 60 plus 30, so that's 150. But that plus this angle right here have to add to 180 degrees. So this, I said 60 plus 60 plus 30 is 150 degrees. So that means Z has to be 180 minus 150, which is 30 degrees. Also, another approach is actually go to P first. So I said before that X and P, these are the measures of vertical angles, so they have to be the same. That means that P has to be 60 degrees. And then notice here also that these two lines, TM and AO, are perpendicular to each other. So that means this angle here, Z plus P, these two angles are complementary to each other. If I know that this is 60, then I know that this has to be 30. So a bunch of ways to set this up, but we're using the ideas that we've developed in this unit or in this chapter, in this lesson, to solve this. And uh, one one secret to good problem solving is to, once you've solved a problem, go back and see if there's another way to solve it. See if there are ways to kind of check yourself. Like for example, you could go in here and look at from here to here. You realize, oh, this is a line, so these should add to 180 degrees, and then you open up to yourself different ways of solving things. Uh, to improve your problem solving ability, when you're done solving a problem, don't just move on to the next thing. Look it over. Ask yourself, is there a different way for me to do this? Check your answer. Step back and look at the big picture. What was my process in solving this problem? And that's how you can develop into being a better problem solver. So again, thanks for watching. Don't forget to like and subscribe.